I would like to introduce Levente Chikor, a senior scientist at the Institute of Info Communication Research at A*STAR, who will be presenting Achieving QUIC's Full Potential, how a DNS deployment gap is limiting HTTP3 performance. Levente has traveled from Singapore to join us, and it is my pleasure to welcome him to the stage. It's also his first NANOG and first presentation. Please join me in welcoming Levente.
Thank you, Ron, for the introduction. So, in short, my name is actually Levy. It's easier to remember me like that. As he pointed out, I came all the way from Singapore, where I'm working as a senior researcher for A*STAR, which is a government-funded national research agency. My background is actually network security and privacy, but I've been having some background as well in pure networking, because when I was doing my PhD, it was mostly about networking only. And as he mentioned, this is my first time at NANOG, so because of my background, I usually attend academic venues, so I'm very honored to be here on an industrial event like this to see real people, real problems, and real solutions, not just pen and paper ones. And the reason why I'm here, because due to network security and privacy-related research that I'm doing, I do a lot of traffic analysis, which usually ends up in looking into packet traces and seeing things, what's going on there. And then I find something strange, so I was trying to dig deeper and propose a talk to NANOG, and that's how I actually came here. So if I want to talk about my motivation, so I think 1 year ago when I was just randomly doom scrolling LinkedIn, I find some people sharing some of these animated GIFs about, did you know that what happens under the hood when you visit the website? It's not just going to the website. There is also some TCP handshake. There's some DNS happening up front. And then other people came that, no, there's also TLS because everything is encrypted. And then the other people come from CDN. Well, no, there's also CDN. So I was like, okay, guys, you are talking about a lot of these extra packets, but even if I look at your very fancy animated GIFs, I only see like 20 packet exchanges. But when I see my PCAP files usually on my own computer, I see way more than that. So that's how I started to look into what I'm actually going to talk about. So one of my vacation times, I was basically trying to do the research on this. So I was just going to Airbnb, and at the same time, I was collecting my traffic trace, and I was surprised by the number of packets that I was actually seeing that was generated by my browser. So I saw that it can even be just 6,000 packets just to load the index page without all the extra media elements. And that was a kind of like a surprising discovery for me. Of course, it's not always 6,000 packets. It can be sometimes 4,000. But anyway, it wasn't that 20 that I saw people were sharing. And from the security point of view, what I saw is that it's not going to get anything better, right? We are always about now privacy and security. We're just topping it up with every single layer. We increase adding more and more layers, which eventually requires more and more handshakes, which ends up more and more packets, which at the end is going to increase the latency. And then I was like, there's going to be a solution for this as well. And I was like looking at this new protocol called QUIC. It's like, okay, maybe I should look into that. Maybe QUIC is the answer for all the number of packets that I see, and maybe I'm just really not up to date what is going on. So what I was doing that I checking like what is the rise of QUIC nowadays. So there was one website that I did some quick check like September 2025 when I first submitted my talk, and then I saw that there's like 8.6 million websites nowadays that support QUIC. And then just 2 weeks ago, before I took my flight, I checked the website again, and I was like almost 9 million. So within a few months, we basically have more than 400,000 new websites that are basically supporting QUIC. And of course, I don't want to go into what QUIC promises on top of TCP. This talk is not about QUIC, but just the key improvements that people usually say is that it eliminates all these head-of-line blocking that TCP is notorious for. It has a faster connection establishment. It can have even 0 RTT. And because it supports encryption by default, all the security people are happy too. But eventually, when I did some very basic analysis to go into google.com, and I used encrypted DNS to actually go into there, but it's not what you have to see on this page. But I was seeing that if I actually use TCP, if you look at the right-hand side, so you can see the number of packets and the time to load on my plots. And I was saying that if I use TCP, actually, I'm generating less packets than if I use QUIC. And that also turns into the latency at some point that I saw that if I use TCP, my access to the websites, the time to first byte basically is faster than if I'm using QUIC. So it's like, it's not something that I read on paper and it's supposed to happen. So I was like, okay, maybe this QUIC protocol is the fastest protocol on paper, but it's basically running late a little bit. So let me give you a little bit of background from a security point of view of some of the evolution of what was going on under the hood. So we all know that the HTTP is already HTTPS. For the last 2 decades, I think more like 97% of the clear internet is fully encrypted. But the privacy people were always saying that the DNS always remained plain text. Of course, there was a reason for that, but the privacy people were always saying that DNS on its own reveals a lot of information. But from the network operator's point of view, they can always say that, yeah, you have that problem, but at the same time, there's a lot of benefits of having DNS as a clear text, because I can use DNS as a network operator to block malicious domains. You can even use it for blocking ads, and even some of the parental controls from normal ISPs, they're all based on DNS. So there's a lot of services based on DNS. But anyway, the privacy people are privacy people, so they don't care about any of these things. They were like, let's encrypt DNS no matter what. So then in 2016, DNS over TLS has been standardized, and it was followed by DNS over HTTPS in 2018. And then basically 4 years ago, even DNS over QUIC, I think maybe many people didn't even hear about that, but even DNS over QUIC or DNS over HTTP3 was standardized already in 2022. And then again, the privacy people just took it to the next level, and they say, okay, now you encrypt DNS, but eventually if you just look into how connections are being established, you are using your TLS handshake when you're connecting to somewhere, and then when you're asking for the certificate from that specific website where you want to connect to, you have to tell this in your client hello. So you're basically still exposing this information. So if you are like an authoritative regime or just want to use censorships, all these things can still work even if you encrypt your DNS. So then again, the community moved on, and then they saw, okay, then we can use TLS 1.3, and it has this extension of encrypted client hellos, so we can even encrypt that client hello. And this was also standardized in 2020, so it's like not a very new technology. So whenever it comes to encryption, it always have to have some key exchange, right? So since now TLS is encrypted, we need to share keys up front. So that's how basically DNS was again used for other purposes than just domain name resolution. So that specific record type of DNS, which is called HTTPS, was gaining some traction. It's not necessarily just for this, but it has been used for specifically this of how to distribute the encryption keys for encrypted client hellos. So it was gaining a lot of traction back there, and it's already been standardized again in 2023. So nowadays, your browser will ask for these records if you enable this crazy privacy mode. So like you want to use encrypted client hellos, you're encrypting DNS, and then your browser will actually ask for these records. And why crazy privacy? Because if you anyway don't encrypt your DNS, there is no reason to encrypt the client hellos because you are already exposing that information. So these records were basically evolving. So it wasn't just about this information to be imprinted. So if you look at the RFC, it says that these record types can be used to provide alternative endpoints, which is like usually these IPv hints. So let's say one website resolves to a certain IP, but if the actual website is provided at the alternative endpoint, you can imprint this information into DNS. You can also put this information into DNS to provide non-default TCP or UDP ports, so you are not required to run your web service on port 80 or port 443. You can also indicate some extra thing like HTTPS scheme, which means that you can tell to your browser upfront, then don't even try to connect to me using port 80 because I'm going to redirect you to port 443. And then eventually we also have this information as QUIC has evolved into the standards and penetrated the internet, then you can indicate QUIC option in your DNS as well. So I was like, if all the standards are there, then why do we still see so many packets, and why I'm seeing more packets using QUIC than TCP? So then I found this kind of challenges that how I can end up to this situation. So first of all, there is this encrypted client hello paradox of the browsers that I saw, that they only request these specific records if you are enabling this crazy privacy mode. This is something that actually, if I remember correctly, Jeff Houston was referring to in his last NANOC talk about how many browsers were actually querying these records. So this is kind of like an answer for that, because by default, they don't ask for this record. But if you are like crazy privacy person and do some extra setting in your browser, then your browser is going to do that. So it's an ironic twist, right? So you need to enable this extra security layer to eventually make your connection faster. That's not something that goes along the line. The second thing is the DNS knowledge gap. So website administrators, they often lack expertise in DNS. So I think yesterday's keynote, Omar from Meta was talking about that don't just focus on one protocol or just one side of the stack. You need to have a complete view to understand how things work and where you can innovate. And then the third thing is about this efficiency dilemma, which was that actually when browsers go into website and they try to identify whether QUIC is supported, they do all the things with TCP first. And then after they do the establishment, then they can get from the application layer that, hey, by the way, there is QUIC, you can use QUIC as well. So if the way how I started my research is that I built some basic containerized applications which I can use to automatically visit website to ease this whole analysis. So it's fully containerized, it can eliminate all the background traffic, and I can toggle things that use DOH, use QUIC, use ECH, use even Tor, so that I can really easily gather a lot of PCAP files, and then the whole thing that is fully isolated, and I also store the encryption key so I can see what's happening in the application layer, and I can process all the PCAP files, and that's what I can do. So then what I tried to do is that I went to Airbnb again. So full disclosure, I have no affiliation with Airbnb, and this is not a revenge because of not getting any refund last time back. It's just about my first website that I tried and I saw this. So basically when you freshly start your Firefox browser, that you have a lot of background traffic that is happening connecting to all those Firefox services, then it uses TCP, it uses TLS, so then you do OCSP for those certificates as well. And eventually after a fresh start, the first meaningful packet, which is still not a meaningful packet, but that's the first DNS packet that is going to Airbnb, is happening after like 200 packets, which is fine. I mean, the first 200 packets anyway is just happening when you freshly start the browser, which the users don't usually do very often, right? So we can still think that this is like packet number 1. But anyway, then later on we can see that basically the first actual TCP packet, which is going to port 80, is happening around 700 packets later on. And then we see that we are being redirected to HTTPS. So we go first port 80, then the HTTP header is telling us that, hey dude, what are you doing? Still HTTP? Go back and go to HTTPS. Then the whole thing starts again. You start again a new DNS request to the same domain, even if you just did a few seconds ago. Then you do TCP SYN on port 443. Then you do the TLS handshake. Then you got the certificate. Then you verify the certificate using the OCSP protocol, whether it's still valid or not. And then eventually I can go to Airbnb.com on port 443, then it is telling me that, hey dude, Airbnb.com is just the backend service. You want the website, you need to go to www.airbnb.com. So then the whole thing again starts over. I do the DNS query for www.airbnb.com. Now at least I know it's port 443, so I don't even try port 80 anymore, but still I use the TCP SYN. Then again a TLS handshake. Then eventually, the first meaningful query byte happens almost around 1,000 packets. That's where I'm basically going to www.airbnb.com finally. And then the whole thing starts to happen for the CDNs as well. So because I download the HTML site, I will see where all those third-party things has to be downloaded. So then there's a DNS for CDN. The whole thing just coming up again. TCP, TLS handshake to the CDN. And basically, the first time when you see some indications about QUIC is coming from the CDN in a HTTP OK response, where they see that you can see that there is this alternative service being imprinted in the HTTP headers. And then it says H3 port 443. It means that, hey, I support actually HTTP 3, which is QUIC, on the same IP at the same port. So you can come to me by using QUIC. But anyway, I already connected to TCP, so it's not going to be a cold switch, so I'm still maintaining my TCP sessions, but I can slowly go to QUIC for sure. So the first initial QUIC packet that eventually happens to Airbnb.com is around packet number 1048. And then I'm still going to have a temporary redirect again because I was browsing the website from Singapore, so I had a regional redirection. So again, all the things started again and again and again. And then eventually I ended up connecting to Airbnb.com using QUIC at packet number 1134. So I wasted like 1,000 packets to get even the first byte from Airbnb, which was quite surprising to me. So it's just 1,000 packets here, but the reason why we see actually 6,000 packets, because it doesn't mean that from now on everything is QUIC. There are like multi-threads, multi-TCP sessions are still open in the background. They need to close it. And the whole thing basically happens because all these backward compatibility. So you need to be able to fall back to TCP at the end. And it's also happening because you don't know that information up front that someone is supporting QUIC. So you need to do the whole establishment from using TCP first, and then you will be able to see whether QUIC is working. So let me tell you how it's supposed to work in the modern web. So we can actually piggyback the DNS and use this HTTPS record. It's even the standard is saying that you can use this information. You can use this DNS resource record type to imprint this information. Of course, then your browser can ask for this. Once you know the A record, so you know the IP address, then you can ask for the HTTPS records, and you can get to know all these extra information. So your browser can straight away go to your website using QUIC, which eventually can significantly reduce the packet sizes because QUIC is based on UDP. So straight away you eliminate the TCP handshakes. It's encrypted by default. What does it mean? That your browser won't even try connect to port 80 using unencrypted communication. So those handshakes and those redirections you can also eliminate. Then the third point is that since it's encrypted by default, basically the first QUIC initial packet already has the TLS client hello baked in, so you don't have that extra TLS handshake either. So I was like, is it something new that I discovered and nobody's picking up? So I was just doing some more research, and I realized that the state of the art is that Cloudflare knows this very well. They even have a blog post about it from 2023 where they say how it's supposed to work, what is QUIC, how you can benefit from it, and they even say that they actually basically enable this for all of their customers by default. So if you use a dig query, you can see on my screenshot that this is how a HTTPS record look like. So you will see that ALPN, which is the application layer protocol negotiation. So you see H3 there, you saw the IPv hints there, so it can basically tell you using DNS that, hey, I support QUIC and HTTP3, and this is the IP you're supposed to connect to using IPv4 or IPv6. All the information can be there. So then I was like, okay, what can I do if I also want to benefit from this? I cannot wait for the whole internet to catch up. So for me, the problem was clear. I was like, I need to somehow augment all these DNS responses on the fly. So I was trying to develop something for myself. So this is not like a carrier grade thing. It's more like for evaluation. So my aim was that, okay, I need to augment the DNS responses on the fly, and I want to do it locally. So I don't want to interfere with any of the whole internet ecosystem. I also don't want to run any modified local DNS server and copying from recursive resolvers or authoritative servers what IP addresses I'm supposed to put in. Then I manipulate the entries and add these things to my whole DNS server, because I would definitely end up in inconsistency very fast. And I can also gather this intelligence upfront, so I know from the HTTP headers which websites actually have QUIC, so I can do that. And I also wanted to have a solution for myself which is transparent, which doesn't require any add-on or anything that I have to install on my machine. It still has to go through the usual process. So the thing that I was doing is I use DNS-dist. It's a simple, freely open source application developed by PowerDNS. Its intention is to be a DNS load balancer and a proxy, but I can also use it as a stub resolver. So I can just run it locally, and basically you just set what the backends are, so it doesn't really matter. The other good thing of DNS-dist is then it can provide encrypted access to the upstream. So if you're still really privacy enthusiast and you don't want your DNS to be clear text, then you can still use DOH and go to Cloudflare, Quad9, Google, or all the other hundreds of encrypted DNS. The other good thing is with this DNS-dist that it also supports encrypted access to the downstream. So I can ask my local stub resolver using encrypted DNS. I know it doesn't make a lot of sense to encrypt everything locally, but if you think about the fact that those browsers are still stupid at some point and they only ask for the HTTPS records if you are using encrypted DNS, then this was a no-brainer for me to use this, so that I can enable encryption both sides. And the most important part was that this is not just a simple proxy, so it has a Lua interface when you can use to hack around a little bit, so I can actually manipulate the messages. So then I can build up two different approaches of how I can make my own internet faster for my analysis. So I can do this matching on those HTTPS records for the main domains, like let's say www.airbnb.com. Or if I'm a little bit more advanced and I know that there's going to be CDNs and I gather all the intel upfront, then I can also set those extra information into the HTTPS records for those specific domains. And they have all these simple utils that you can use. It's like a very simple thing. You see that you just put in your string whatever you want the HTTPS record to look like, and it gives you the hexadecimal representation. And then on the other side, you can see how easy it is to extend DNSDIS mechanisms to actually spoof those responses. So you can see that I'm matching on www.airbnb.com, airbnb.com, and a0masscache.com, which was a CDN used by Airbnb, at least back then. So you can see it's going to match on the HTTPS records, and it's going to spoof that information into the responses locally. Again, everything happening on just my side. So then I was doing some analysis to see, like, would it really make sense to do this? And I was going to airbnb.com again like 100 times. And then on the left-hand side, so the whole plot is about the number of packets being generated. And I see that in my current internet, you can see there's actually a huge range of how many packets I'm actually generating from time to time. And I can significantly increase that. So in the worst case, I was even able to achieve a 50% reduction in the number of packets if I'm really advanced and I just set these specific records for all the domains that are being considered during this connection establishment. And with this reduction of number of packets, I was able to achieve that the first QUIC packet eventually happens on average around 20% earlier. So what does that mean? That 20% earlier QUIC packet means that basically the time to load the whole website from the beginning, I can really reduce it for to be like 20 to 35% faster. This is also not just for Airbnb to have happy customers like me. This also has implications on the network itself, because I'm generating most likely less throughput and a lot less packets. So then the network operators and all the switches, they don't have to process the same amount of packet. And then I'm just talking about myself. You can imagine that if everyone would use this, how many more packets can be spared. So this slide's supposed to be animated, so sorry about that. It's a little bit dense, but let me walk you through. So I was asking for myself that, is everybody doing it wrong except Cloudflare? So in the research community, we have this kind of Trenko list of top domains. So I was looking for that first. It's just a well-curated list. You don't have to understand how they make it. It's just, let's say, the first top 1 million domains based on how many people are going there. So I was checking the first 5,000 of those. And I was trying to see like how many of them support QUIC. So I connected to all those websites and get the information from the HTTP headers that basically 25% of those domains, they support QUIC. So then I was like, okay, let's see the DNS record types for those domains. So then I saw that more than 50% of those domains, they actually have HTTPS records, which was good to see that at least they know that this record exists and they have this underlying thing. But if I really want to look into that which one of those actually put H3 in their records, I saw that only 30% of those domains which support QUIC, which if you put it into numbers, it means that from that specific first 5,000 domains, which have those 1,254 QUIC-enabled domains, only 70% of those sites, they have zero benefit. They are making actually things even worse. And then there's another list that I can use. This is more like industrial, I think, a little bit. So Google Crux list, that's the name of the other thing. It's a little bit differently curated, but it's still about the top 1 million domains. So again, I took the first 5,000 domains. Then I did the same analysis. There was at least something surprising that I saw, that even if the QUIC supported websites is nearly about 40% of those 5,000, more than that have actually HTTPS records for the corresponding DNS entries. But still, they didn't use H3 appropriately imprinted into the DNS. So only 2/3 of them was using this. So which eventually translates into the fact that, again, from those websites, 1/3 of them, they have zero benefit. Even if they have QUIC, they really have zero benefit. So when I was looking at like all those IPv hints, those alternative endpoints information into the DNS records, I was like, okay, let's see that how many of these websites are basically Cloudflare-based websites. And I found that basically 50% of the providers are from Cloudflare. So I was checking all those IPs with the reverse DNS resolution and see whether they become Cloudflare or not. So besides Cloudflare, what I saw is that like there's Ripe, and then some of the hosting providers that seem to know this, and they maybe silently or transparently enable this for their customers. So still, I can say that maybe still at this point of time, only Cloudflare is doing that well. So for my future work, so this whole apexDNS that I developed, this is really just a proof of concept to play around with and see what is missing there. So it's just a bunch of script to basically hack my own internet and make these measurements. and do evaluations. It doesn't come with, I mean, you can download it from GitHub and you can try it for yourself, but it doesn't come with any preloaded HTTPS records for all the domains that are out there. Especially that you might regionally have to adapt it to other IPs. Like the IPs you see from the DNS in the US is completely different than what I see from my DNS in Singapore. Of course, I have a plan to automate this process, but it's a longer thing to do. So if I want to summarize the main takeaways that I wanted to emphasize during this talk, is basically the problem is quite clear. So QUIC is only QUIC if the client knows about it. And this small piece of missing DNS information basically ends up in a wasted protocol overhead. And it's always about the DNS, right? In security people, we always say that it's not a DNS, there's no way there's a DNS. And then at the end of the day, it turns out that it's always a DNS. So even in this case, which is not really security related, it all boils down at the end that it's all about the DNS. So for the network operators and who are providing all these services, I think we just really need to adopt this record and use it. It's standardized, it's there. Browsers will pick it up soon. So just put it there and make your clients happy. And for the customers, of course, whose network operators are not present here and they are not listening to this, they can just try to have some experiment with my tool to see whether there is any benefit. And one thing that I saw that you need to update your browser. Now I started to see in the last half year that the latest version of the browsers, they ask for these HTTPS records no matter how crazy privacy mode is enabled, which is kind of like beneficial. So even now the browsers are picking this up. So maybe if Jeff is doing his research next year, he might be able to see more browsers asking for these records. So just keep up to date, adapt the latest standards, and then you can have all the benefits. Thank you so much, and that would be my talk.
We have some time for questions. If anybody has questions, please remember to introduce yourself and the company you're representing before asking your question, and lean into the mic. Thank you.
Jeff Houston, APNIC. I did this measurement back late last year, and what I observed at the time is that Google's Chrome browser, which is the predominant browser out there in the ecosystem, does not ask for HTTPS records and relies on the alt service mechanism to trigger it. I also observed that the Apple ecosystem and the Safari browser does not look at the alt service record, but instead goes directly to HTTPS. And so when you're doing a census of who's doing HTTPS queries, you're picking up the difference between the Apple ecosystem and the Google/Android ecosystem. My question is not to you. My question is to anyone out there in Chrome land. Why aren't you querying for HTTPS, please? It makes this whole thing, as you point out, faster, more efficient, more predictable. And if, the server doesn't support HTTPS, it doesn't use it. But if it does, this triggers it immediately. So great work and a great observation. I think the ball is now in the court of the Chrome folk to go, why aren't you listening to us? Why haven't you picked this up? Thank you.
Yeah, thank you for the comment. One thing that I can, no, sorry, I'd rather let the people to ask first.
Charles Rumford, Summit Hosting. SSH has a similar record, the SSH FP record, but in the OpenSSH protocol, the OpenSSH application requires the DNS record to be DNSSEC verified, otherwise it rejects the record. Do the browsers do the same thing for the HTTPS record to ensure that it's like legit and not hijacked?
No. DNSSEC has nothing to do with this kind of security thing, so it doesn't have to be DNSSEC for the records. The HTTPS records are just...
But then how do you verify that someone hasn't intercepted that record somewhere else?
They might need to do that, but as I saw, I just hack my own responses and they don't care, so they don't verify.
But that's my point.
So, excuse me? Yeah, sorry.
Wes Hardiker, Google, not speaking for the Google browser. I've been with Google for 4 or 5 months. I know nothing. So I would love to see the continuation of your studies that included various measurements of caching, because that is where a lot of operators go, oh, well, you know, they've been there before. It's going to greatly reduce the number of packets and the latency and everything if you just cache everything. And RFC 9199 actually talks about the DNS side of caching for large resolvers or large authoritative servers, of which I'm an author to disclose. But one of the things that we put in there is stop caching at stop putting in TTLs for DNS records at 5 minutes, right? That is way too short, and you get a lot of benefits for all the users of a resolver if you put in like a cache of an hour and you get rid of DDoS attacks and all sorts of other things. But even HTTP records have the ability to say, don't come back to port 80, right? So there's headers saying, once you've hit port 80 once, go back to HTTPS, just as Jeff said, some start that way. So it would be very interesting to see your results, again, from multiple browsers, as Jeff indicated, as well as, what are the effects of caching? How much does that help? And don't get me wrong, I would love to see all of that cruft reduced so that you get, data faster than packet 1,000. That's crazy.
I actually see that some of the browsers are trying to build their own caches. So once in the beginning, if I use all these extra round trips, maybe the next time they don't do that anymore. So even the port 80 to port 440 redirection, you can just force your browser to always use the HSTS scheme, so it doesn't even try to connect to port 443, and they can pick it up slowly. But at the same time, which I never understood, is that even within the same connection, when I go to Airbnb, within the same seconds, it basically, for the DNS, it asks for the same domain name again, because maybe it has changed, but still they have like even 5 minutes. They don't care about 5 minutes. I go to Airbnb, then few seconds later, still Airbnb.com, and I still see the DNS queries being done. So that is something that I don't completely understand why they do it, but maybe it has something to do with caching, and they just don't want the information to be cached so long because they think that things are changing faster than that.
I'll end with a side quote that you didn't hear from Jeff, which is, welcome to the DNS.
I'm sorry, that's all the time we have for questions, but I'm sure that Levy will be happy to speak with you on the side here.
Thank you so much.
Thank you, Levy. Great job. Thank you.